Hi geometry students. In this video we are going to work to be able to justify that triangles are similar using the angle-angle theorem, the side-angle-side theorem, and the side-side-side theorems for similarity. So first of all, we have the angle-angle theorem for similarity, which states that if there are two congruent angles in any triangle, then obviously the third angle must be congruent as well. And so therefore the triangles must be congruent. So if I look at a picture, maybe I'm looking at this. So these two triangles, I got to make them a little bit different sizes here. Okay, so let's say this is triangle ABC. This is triangle DEF. And I have a single mark in A and D, and then two arc marks in C and F. Okay, I would be based on those arc marks, I would be able to say that triangle ABC is similar to triangle DEF. Okay, I can also possibly see that in another way. Let's make this a little bit. So let's say that I marked in this. Let's say that I mark angles A and D congruent. Okay, I know because at angle C, these are vertical angles, that angle ACB and angle DCE will be congruent. So by looking at these two triangles, I have two angles marked congruent in triangle DCE and in triangle ACB. So I can say that triangle ACB is similar to triangle DCE. Now notice when I mapped my similarity statement that I matched A and D together because A and D have one arc mark. I also put C and C in the same place because they have the two arc marks. And then last but not least, I put B and E in the last slot because they do not have the arc mark. All right, so that's one way of proving that two triangles are similar. Another way is if I have all three of the sides marked. So if three sides are marked proportional, okay, to each other, then the triangles are similar. So I'm going to go ahead and draw two triangles. This I think is the hardest one to check because you have to check all the sides. Okay, so let's say that I have triangle DEF and triangle BAM. Okay, side DE in the first triangle is 2, and side BA is 4. Side EF is, let's go, 5, and side AM is 10. And let's say side DF is 6 and side BM is 12. And we're asking if triangle DEF is similar to triangle BAM. So what we would check if these are similar is we check that the corresponding sides have the same scale factor, same ratio as one another. So I'm going to check DE over BA. That ratio has to be the same as the ratio, I'm going to highlight these, right? So DE and BA, as the ratio from EF to AM, EF to AM. And that ratio has to be the same as the final ratio of DF to BM, right? So DF and BM. And again, this is what we did actually last week, Friday, where we matched up all the sides and we checked the ratios. Okay, as I look at this, DE over AB, I'm going to move this down a little bit. So DE over AB is 2 over 4. EF over AM is 5 over 10. And DF over BM is 6 over 12. So we see for all three of the sides, they have the same proportionality or same ratio, which is 1/2, right? So the smaller triangle is half the size of the bigger triangle. Okay, and we can look at that and say, what's the scale factor from big to little, right? Triangle, or from triangle BAM to triangle DEF. Okay, since the smaller one is half the size, that's the scale factor is 1/2. Okay, so big to little. All right. And then the last option for us proving that two triangles are similar is side angle side. And with that theorem, we need to have two sides that are proportional in the triangles with the angle between them being congruent. So I'm going to draw a picture of a scenario where this might be the case. Right? So I'm going to mark this as triangle DOG, and this is triangle BEG. All right, so we're going to mark this side. We're going to check if triangle DOG is similar to triangle, let's do BEG. Okay, so we're going to mark side OG being a length of 9, side EG a length of 8. Let's do 3. I know it doesn't really look like it, but we'll make it that. Let's do DG a length of 12 and BG a length of 4. Okay, so I see, first of all, when I'm looking at this picture, I see that at angle G, I've got that vertical angle. Okay, and then I'm looking at this, I'm saying, hey, the angle in between two sides, right, is being marked. Now I'm going to partner up OG with its a corresponding side in the triangle. So in OG, that's in triangle dog, and then I'm going to match that up with the side in triangle bag. Okay, so side OG has to be corresponding to side EG as side DG has to be proportional to side BG. Okay, so we can do a quick check here. So 9 has to be proportional to 3 as 12 is to 4. Is 9 to 3 the same proportion as 12 to 4? Yes. So by side angle side, we can say that these triangles are similar. Okay, let's go ahead and practice this with some problems. Okay. If I look at this, I'm going to first go ahead and find the third angle, right? Because right now I see one angle is marked congruent. E and B are marked congruent. And then I see two different numbers, but that doesn't necessarily mean that there's not another angle that's congruent. I want to find the third angle in both these triangles. Okay, so in this triangle, I'm going to take 180 and I'm going to minus 90 plus 47 to find that third angle. And what I'm getting is 43 degrees. So right there, that tells me that I now have two angles congruent. So I can say yes, triangle, and then I'm going to say triangle ABC is similar to triangle. All right, that was 43, so that goes with angle D. And then the 90 degree is angle E, and then F by angle. All right, let's check here. Okay, so here I've got two sides marked, right? Tick marks, so they're isosceles. Okay, so I know that whatever the proportion is for this side to this side, it's going to be the same as the proportion from this side to this side because I'm going to be doing one tick mark is to two tick marks as one tick mark is to 2 tick marks. So I don't really have to worry about that. So I know the sides are proportional. The question is the angle in between those sides? So I have to check and see if angle B is going to be 40 degrees. So what I'm going to do is I'm going to go ahead and say, since this is an isosceles triangle, angle C is 70 degrees. And then I'm going to go ahead and finish my math here and say, what's the third angle in the triangle? I have to do 180 minus 70 plus 70. So 180 minus 140. So angle B is 40 degrees. All right, so now I can say yes, triangle ABC is similar to triangle, let's go PQR by side angle side. Now notice that I am matching my angles up with each other, right? So A and A, let's use a different highlighter color. A should go with P, right? A and P, and then B is the tip, right? That's where the 40 degree is. And then I go back to R and C. Okay. All right, let's try a couple more of these just to make sure we're really getting the hang of it. Let's go ahead and do a side, side, side one. So I'm going to verify if these triangles are similar. So first I'm going to kind of look at this and say, all right, so when I look at these sides, it looks to me like this is another isosceles example, right? So we can say 1 and 2, right? So I need to check that side PQ is to ST as side QR is to side TU as side PR is to side SU. I'm going to go ahead and just check that proportionality is the same all the way through. So 3 is to 4.5 as 3 is to 4.5 as 2 is to 3. And a quick check, I'm going to do 3 divided by 4.5. I know that 2/3 is 0.6 repeating. So I'm going to just check what 3 divided by 4.5 is really quick. Oh, good. That's also 2/3. So these are all 0.6 repeating. So I can say yes, these are similar by side, side, side. All right, I want to check. Now I know that these are vertical angles in this next example, so I can mark those congruent. So now in my head, I'm thinking side angle side because I'm seeing that scenario where I've got two sides surrounding the marked angle. So now I got to kind of figure out how these match up. So it looks like I'm going to be matching WX, and WX seems to match up with UX. So WX has to be to UX, as then I'm going to be matching up XV to TX. XV to TX. Okay, let's check it. Is 20 the same proportion to 15 as 16 is to 12? If I reduce both of these, this reduces to 4, divide by 5, 4/3. This reduces, divide by 4, this also reduces to 4/3. So yes, these are similar by side angle side. All right, let's go ahead and do a little bit more where we do apply some algebra, where we're going to actually find a full side length using our similarity statements. So first, I'm going to verify that these sides are, why these triangles are congruent. Okay, so if I look at this, all right, sorry, not congruent, I'm sorry, they're similar. Okay, if I look at this, these angles are the same, okay, which tells me that these lines must be parallel, right? And if these lines are parallel, then they're going to be parallel down here as well. So these angles must also be congruent. So I know that triangle RSV is similar to triangle RTU by angle-angle theorem and my use of parallel lines. Now I'm going to use that to find the measure of RT. So I want this whole length here, right? So I'm going to say, I'm going to look at the ratio of the small triangle. So I'm going to say RS is proportional, right? So the small triangle is to that same side on the big triangle. So RS is to RT. As now I'm going to look and say this side, so VS on the small triangle, that looks like that's kind of like the base on my triangle if I turn it sideways, VS has to match up with UT. So I'm saying small side, top side on the small triangle is corresponding to the top long side on the big triangle, as the right or base side on the small is to the right or base side on the big. Let's check mathematically so that we can solve. Our job is to find RT. So let's go ahead and start filling in what we know. RS is 10. RT, I don't know. I'm going to leave that with an X. VS is 8. And TU is 12. So we're going to solve this proportion by cross multiplying. So 120 is equal to 8x. Divide both sides by 8. And x is what? 120 divided by 4 is 30. So that's 30 over 2, which gives you 15. So x would be 15. And x is the length of RT. So RT is 15 units. Okay, let's go down to example 5. This is going to be our last one. We're going to explain why the triangles are similar. Again, we're going to use this whole, like, these are parallel lines, right? So we can use angle-angle theorem for this. If these lines are parallel, and this is a transversal, we know that these are alternate interior angles. So those will be congruent. And then these will also be congruent. Okay, so I can kind of look at this as the small triangle and compare that to the big triangle. Okay, so I can say that triangle BAE is similar to triangle CAD by angle-angle. And now we're going to go ahead and find the lengths of BE and CD. So we're going to set up proportions for them. I'm going to start with finding the length of BE. Actually, yeah. Okay, so we have to find the length of x, so it doesn't matter. We're gonna have to solve for x first. So let's side AB is to side AC, as side BE is to side CD. All right, so what I did is I said the top side of triangle BAE is similar to the top side of triangle CAD. And then the right side of triangle BAE is similar to the right side of triangle CAD, or small is to large as small is to large. All right, now let's go ahead and fill in those blanks. So AB is 3. AC, that whole length is 3 plus 4.5, so that's 7.5. As X is side BE is to X plus 6. And then we're going to go ahead and cross multiply, which gives us 3 times x plus 6 equals 7.5x. We distribute, we get 3x plus 18 equals 7.5x. We need to get all of our like terms on one side, so we're going to subtract 3x from both sides. And we get 18 equals 4.5x. And last but not least, we divide by 4.5 on both sides. And 18 divided by 4.5 is 4. So x is 4. And our job was to finish this by finding the length of BE and the length of CD. If x is 4, that means that this length is 4, so BE is 4 units long, and CD is 4 plus 6 units long, which gives us 10. All right, that's it. I'm going to let you guys go ahead and do your practice. I know that was a pretty long video, but you still got 30 minutes to work.